So welcome back to calculus. I'm still working on implicit differentiation. This is the second video to try and get through that. I really just had this one example that I want to do. It's going to take me 2 boards to do it, but I want to look at finding a second or higher order derivative using implicit differentiation. So I want to find y double prime, second derivative, for y squared minus 2x is equal to 1 minus 2y. Well, if we want a second derivative, we have to first take the first derivative. So I take the derivative of both sides with respect to x. On the left, the derivative of y squared is 2y. Again, don't forget the dy dx. Y is its own little function, and it gets its own little derivative shoved in here. Minus, and the derivative of 2x is just 2. That's nice. Is equal to, on the other side, the derivative of 1 is 0, so that's gone. The derivative of negative 2y is going to be negative 2, and then again for y we get a dy dx. So be really careful there. So now I'm going to rearrange this to try and get that the dy dx by itself. So I started by moving this term here, the 2y dy dx, to the right. I just liked it a little bit better that way because I didn't have any terms on the right that didn't have dy dx. So I subtracted that. You can see that there. Then I factored out the dy dx, which gives me negative 2 is equal to dy dx times negative 2 minus 2y. I divided, and then once I divided, I realized I could clean this up. Everything in this is divisible. Each term is divisible by negative 2, so I went ahead and did that, which gave me a much nicer looking 1 over 1 plus y for dy dx. So there's our first derivative. I'm going to bring that back in for the next board, and we'll work on finding that second derivative. All right, so finding the second derivative now. So we have our derivative. dy dx is 1 over 1 plus y. Since I know I need the derivative of my derivative to get the second derivative, I'm going to rewrite my derivative. I think I said this in the section when I covered the chain rule. I like to do these little quotient rules instead as a chain rule problem. So I rewrote this as just 1 plus y to the negative first power. Okay, again, it works out really nice because we just have that 1 on top. So I don't even get a product out of that because the 1 just doesn't matter. And so I'm going to use this for my derivative now to help me get to the second derivative. So I come over here to find the second derivative of y with respect to x. That's going to be really nice because all I have to do is take the derivative of the 1 plus y to the negative first power. To do that, I use the chain rule. I drop the negative 1 down, and I subtract 1 from the exponent. Okay, so again, my u here is this inside piece, the 1 plus y. You can see I have u here to the negative second power. And then I take the derivative of the inside, but on the inside, what's the derivative? Well, the derivative of 1 is just 0. And the derivative of y is 1 times dy dx. So that's where I get this dy dx from. So now I'm here. I have negative 1 times 1 plus y to the negative second power times dy dx. And that looks like a mess, and it is a little bit of a mess, but it's actually not as bad as it looks because I already know what dy dx is. Okay, so in the process of finding the second derivative, we get another dy dx, but we already know what it is. So I brought it back, and since I didn't have a fraction here, or yet, I brought the dy dx back as 1 plus y to the negative first power. And since these have the same base, I can add the exponents. Negative 2 and negative 1 is negative 3, and that allows me to drop it back to the bottom of the fraction, giving me a second derivative of negative 1 over 1 plus y all to the third power. So there we go. That is implicit differentiation. I hope you learned something, and yeah, have a great day. Bye.